Alright, welcome back guys. I got longer hair and a full beard again, so that means it's time for some more examples. Alright, so first problem I got here is find the population standard deviation of the following series of measurements. Now before we actually get into this problem, first thing I'm going to say is if you do not know the formula for the population standard deviation, or any of the standard deviations for that matter, is look in the FE reference handbook. And if you're kind of getting a theme now, is that the FE reference handbook pretty much has all you need. It's all about kind of understanding what the concept behind the question is asking and knowing where to look in the handbook. For this question in particular, it's not that difficult. You can just kind of look up the population standard deviation. But for other problems, you may need to kind of think about, what is this question asking? What's the concept behind it? And learn where that is in the FE reference handbook. And that'll pretty much serve you well throughout the entire test. So to begin with this question, any standard deviation, I would say, first off, find the average. So that's pretty easy. Everyone pretty much knows how to do that now. So let's just add these bad boys up and then divide it by the number of points there are. And that'll give us an average of 27.2, give or take a little bit. So now that we have that, let's look in the FE reference handbook and figure out what the formula for the population standard deviation is. So we can look that up on page 63 of the reference handbook I have linked in the description. And the formula for that, give a little sigma there, is sigma is equal to the square root of 1 over n, which is the number of points you have, times the sum of each point minus the average squared. So there you have that. All right, so let's kind of do that for this one. So big square root. I'm going to start with the first number, which is 24. We're going to subtract the average from that, square it, and just keep going and add these together. Oh boy, running out of room here. 27.2. All right, not the cleanest work from me there. And we'll divide that all by 6. Once we plug and chug all that through, we should get a standard deviation of about 2.03. First question done. All right, final question here is find the quotient of the following. So we got this big polynomial divided by another one. So there's a couple ways to do these. There's synthetic division and long division. And I know you hear the words long division and you're like, ew, gross. I know, but that's the way we're gonna do it because it's a little more flexible. It works in more cases. So to set this up, let's take that top part, write this back out super long, and put this little bar over it, indicate our long division. Then we got x minus 7 on the outside. All right, so to begin with this, you're gonna wanna try and figure out how many times x goes into each of these under here. So for the first term here, you wanna determine how many times x goes into x to the 4th. And you would know x times x cubed would fit that. So you put x cubed up here, you multiply these two together, and you get your x to the 4th. And then now what do you do with this negative 7 here? You just multiply negative 7 times this x cubed, which will get you negative 7x cubed. Now this next part is important because you might get your negative signs mixed up and you might end up adding something you're not supposed to. So what I usually do is I put, since you want to subtract these, I put a negative sign here and then put this in parentheses so that you make sure you do not mess up your negative signs. So that makes sure that you take this and make that positive. So let's just do the subtraction. X to the 4th minus x to the 4th is 0. So that's good, that cancels out. And then this becomes a positive 7x cubed, so it'll be negative 10x cubed plus 7x cubed, which becomes negative 3x cubed. So to keep moving forward, you're just going to keep doing the same thing and taking the next term down, which is 27x squared. So the next part, how many times does x fit into negative 3x cubed? That will be negative 3x squared. So put that up here, and then put that down here. So then keep going, multiply negative 7 times negative 3x squared, which is a positive 21x squared. Make sure you put it in parentheses to get that right. These will cancel out, and then you'll get a positive 27x squared minus 21x squared, which is 6x squared. Then you keep going, take this minus 46x down. How many times does this x go into 6x squared? That will be 6x. So put that up here, put this down here, and then multiply 6x times minus 7, which will be minus 42x. Put it in parentheses. 6x squares cancel, and then we get a minus 46x plus a 42x, which will give us 4x, or sorry, negative 4x. Bring this 28 down. How many times does x go into negative 4x? Negative 4. Put that up there first. Negative 4x there. Multiply negative 4 times negative 7 plus 28. Put those in parentheses, 0. And you're done. That will give you your final quotient of x cubed minus 3x squared plus 6x minus 4. There we go. That's a long one. But I'm sure you guys have done those in the past and it's been a while. But yeah, that should do it for this video. Really appreciate it, guys. If you found either of these helpful, do the things that every YouTuber tells you. Hit the like button, subscribe, comment if you want me to keep going, because I'm really just doing this for myself at this point. But yeah, hope to see you in the next one.